I'd like to thank the organizers for the opportunity to speak, and I don't think I should be considered for the award in this section. It's for one of the young, bright investigators that we just heard from. I don't know if you can read it up there, but that's to remind me, 3 years ago, in June, I just Googled carotenoids for some reason, and there was this macular carotenoids meeting. And I was like, they have a meeting on macular carotenoids? And I'd never heard of it before. But I was considering to start to work on lutein and zeaxanthin because of what I'd heard about age-related macular degeneration. All my work up to that point was for beta-carotene and provitamin A in maize targeting sub-Saharan Africa. And the reason why I was interested in the US, I worked with Harvest Plus, and they were asked in Zambia by the Minister of Health or Agriculture, well, you want us to grow and eat this orange corn and other biofortified foods. Do you grow and eat them in USA? And they said, well, no. And they were like, so is there something wrong with this? Why do you want us to eat these biofortified foods when you don't do it? So I wanted to grow maybe 1 acre and have some chefs serve it and do a school lunch and a little educational program. Then we said we could do it. But I wanted to find out about the benefits to the US. No one argues breeding for vitamin A for Africa, but the age-related macular degeneration seemed like it was population associations, wasn't really clear cut. So I was in a meeting in China, basically with a group of us came in to have this high-level panel assess biofortification for China, and they did. But I came back, and 24 hours later, I was on a plane here, and I was totally jet-lagged. But I told John, I said, John, I have a short talk. If somebody cancels, I'm happy to talk. And someone did, and I talked, and I got a lot of very positive feedback. So that's how I came to be at this meeting here. And I will say that from attending this meeting, if I had 3 years ago, if I'd come for one day and went back, it would have been worthwhile because of what I heard, particularly when they started talking about dementias and things in the brain. Okay, what you see here in this map here is areas of vitamin A deficiency. I'm not going to talk much about vitamin A deficiency, but the darker the orange, the more severe the deficiencies. And it's kind of interesting, the darker the orange, the more they need orange corn that is high in provitamin A. But importantly, all of this is non-GMO. So we don't have that issue to deal with, and Africa doesn't really accept GMO, so we've had to do that. There's a lot of natural diversity for vitamin A. Okay, and I used to just throw this up because I was primarily working on vitamin A, and oh, by the way, yeah, maybe it might have some effects on age-related macular degeneration. But coming to this meeting, I learned about lutein and zeaxanthin and the potential benefits, and now I'm spending more time on working on lutein and zeaxanthin in my genetics and breeding program. And if you went back to the late 1800s in the US, the majority of the corn was white. Corn, when it first evolved, was white, and then there was a gain-of-function mutation that made it yellow. They turned it on in the endosperm. You had it in the leaves, the pathway. And it changed, and in the early 1900s, there was a study at the University of Illinois that showed that there were benefits of feeding animals yellow corn versus white. And I need to dig that reference. I'm going to talk to my Illinois colleagues because it really is a landmark study that hasn't really been well cited. I don't even know the reference. I got it word of mouth from 3 different people. But now, I would like to see corn change from yellow to orange. Same point of thing because of everything that we're learning here. Also, as I said, if we consume it in the US and the developed world, it may help acceptance in Africa because if it's good enough for us, it's good enough for anybody. And as we know. However, to do that, and I do, yeah, this new European disclaimer thing, we formed a startup company, and coming here, my son is the CEO and I'm the CTO, and it's Nutrimaize, and it's for orange corn for USA. So I point that out. But you have to have a startup company. The Monsantos, Dow, DuPonts, Syngenters, there's no market for orange corn, and they're not going to touch it until there's a huge market. So the only way it's going to happen is through a startup company. What's nice about lutein and zeaxanthin, this is the composition of corn on average across the world if you have a diverse panel. There's a lot more lutein and zeaxanthin, and it's more stable. It doesn't degrade as fast as beta-carotene. And so, quote unquote, it's easier. And I used to always want to select for more lutein and zeaxanthin to get more flux into the pathway when we were doing beta-carotene. Now I have reason to do it just for itself. So I've always been selecting for dark orange color visually. And this is the pathway which we've taken advantage of. And we've identified genes here and here to get flux here to stop at beta-carotene. I talked about that a few years ago. Now we want stronger alleles, and they're there, so that we get more lutein and zeaxanthin. Okay, now here, this is something new from last time, is I've been interested in beta-cryptoxanthin for a long time, and there's a movie in the States, if you build it, they will come. And so some of the things I've done in my breeding, I go to these meetings, I hear what the nutritionists say, I hear that they argue and don't agree on anything sometimes, then I make up my mind and I breed for what I think makes sense down the road. And beta-cryptoxanthin, I'm not going to go through the benefits, but it may be, there's studies that say it's more stable post-harvest. You know, it has a hydroxyl group, and it may be more bioavailable. You can argue on bioavailability. I don't care. I'm going to breed for it. So I've been doing that. So we did the genetics, and what we've found is a region here where hydroxylase 4 is that affects the ratio of beta-carotene and beta-crypto to zeaxanthin. And I would like to breed for both. It's easier to breed for both, and we don't know if there are unique nutritional benefits of one versus the other, so we'll breed for both. Okay. And now Harvest Plus is finally listening, and they're going to do a bioefficacy studies, because for about 10 years, a number have been saying we should look at beta-cryptoxanthin. Okay. And so this is a lead. It's the first step. There's more steps, but I'm going to breed for beta-cryptoxanthin, and I do want to ask one of the speakers at break, what about beta-cryptoxanthin? This is my view of the world. All the corn should be orange, or most of it should be orange, and I have more reason to breed for orange because it's largely zeaxanthin and some lutein that makes the corn so easy. But I put that up there as a transition. So this is something color. Well, why study color? So we're actually doing our genetic analyses like we do with HPLC, but only for color. You know, we see color. I mean, we enjoy color. They put up these pictures, and people say, oh, that's so pretty, it's colorful, I'd like to eat that. Orange maize is gaining consumer acceptance in Africa. Oh. Before I go to the next slide, I need to remind myself, after I went to this meeting and we started to look into a startup, we did some research, and what we found, between 2008 and 2014, less fruits and vegetables were eaten in the USA. And despite all of, you go to these meetings, eat your fruits and vegetables. Well, so we were like, corn, we can sneak it into the diet, and corn is very ubiquitous in the diet. So that was a justification. I love your slides and all those pretty pictures, but the reality is people don't eat a lot of fruits and vegetables. So they're going to eat orange corn whether they know it or not. Okay. So in terms of color, orange differentiates maize. You can see it. You know, I show people, I said, this is high in beta-carotene, this is high in zeaxanthin. I go, wow. I've got other corn that's high in iron and zinc, but it's yellow. And they're like, they have to believe me. The orange, they can see it. In case you didn't notice, my shirt is orange, too. Okay. But this is a really cool story. because in Zambia, the men that run and control the markets did not want to deal with orange corn. So a group of women basically formed a out of the system network to deal with orange corn. And in the marketplace, it now sells for more than the white corn that they eat. They don't eat yellow. And that's real economic success. That's real success. So so we're done. Okay. All right. So that's all I want to say is that we have map genes for color, and we're using them in the selection program. And this is just an example where we use these color genes. We got much darker orange color by using that. And I'll just say we now know all of the genes for the pathway. I mean, plenty of the genes to do. And I just want to show two. We know them. And I want to show you this right here. See, I guess I'm pushing too hard. Okay, this was an egg study. But where did I do them? Here we go. People prefer it, and we deliver about 3 to 4 milligrams versus 1 milligram with muffins that are orange versus yellow. And we're doing an egg study, and what you can see is that we have more carotenoids in a diet where we took the yellow and we replaced it with orange, and that's going to be a very bioavailable source of carotenoids. Okay.
Very good. Question from David over here.
You mentioned at the beginning that there's usually great difficulty in changing people's dietary habits. There are cultural preferences. People prefer their white corn. They prefer their potatoes white. Well, one of the ways which of approaching this problem is to introduce it into schools, and you change the children's attitudes to these diets. That gets back to the families. And before you know it, the families have taken over these things as well. I think this is from Harvest Plus themselves, talking about sweet potato.
Yes.
They found this experience.
You have to have educational programs.
Yes.
And the sweet potato has been very effective. Women, particularly pregnant and nursing mothers, are the most susceptible to vitamin A deficiencies, and they're very receptive for their taking care of their children. Also the children are very susceptible. So you have to have education. The good thing is it actually tastes better. It actually does taste better. But the men don't want it, and I've been quoted as saying it more than once, the men can just die off, and the young boys will grow up eating orange corn, and they'll have the benefits. And because the men didn't want to eat the orange flesh, they didn't like the texture. So.
Cultural though, they say that. Once they're introduced to it, it takes over.
Right, it'll take a generation of that.
Okay.
But, yeah.
Any final question before we have lunch and eat corn? Liz.
How high do you think you can go with getting xanthophylls in corn?
Well, I realized this morning I didn't put those kind of numbers up here, and that slide. If I show you one slide, I think I've got a backup. We'll see. Oh yeah, egg. Ask me about eggs, because in the stores it's all over the place, the carotenoids, and it's not worth it to pay for organic. This here was selected only visually for orange color. Now that's about 15 years of work, visual selection. We're just starting to run HPLC for zeaxanthin and lutein, and there's a strong correlation, but it's not a perfect correlation by any means. And so we're 40 to 50 total xanthophylls, and I think in time we could double that. I've seen carotenoids in the 80s. I've seen other labs have said 115 micrograms per gram, but I haven't seen it in my lab. So I've seen in the 80s. So I think we could double it, but it's like the Energizer battery. People are going to be eating corn forever, so we just do a little bit at a time. Does that answer your question? You want it like tomorrow?
I don't know what 40 and 80 is. But,
What?
Well, I don't know what 40 and 80 is, but how does that compare to yellow corn, for example? Just
Oh,
to
well,
get-
yellow it could be 5, it could be 10, it could be 15. It's just, there's no selection in monitoring. So one of the things with orange corn, it's not just that it's, say, 2-3 times higher, but you consistently give people that. With yellow corn, it's all over the place because there's been no selection for it. So it's more, and that's what I do now.